Alright, class. I don't have a whiteboard to use today, so my notebook's going to have to do. We'll be talking about constructible numbers. Thankfully, Bill did all the hard work and showed how to construct all the numbers. I'll just explain what they are and how do you know if you can make them. A constructible number, a number x is constructible if, starting with a segment of length 1, you can construct a segment of length x. For example, 3/5 is a constructible number. Starting with a segment of length 1, you can construct segments of length 3 and 5, and using steps similar to 6.2.1, you can construct a segment of length 3/5. Now, leave that there for a second so everyone can write it down. And that's just a visual similar to what Bill did, I'm sure, showing how to get that length, that segment of length 3/5. Alright, and that brings us to theorem 6.2.4, which is just titled Constructible Numbers. What it states is that if the non-negative numbers a and b are constructible, then so are all of the following: a plus b, a minus b, a over b, as long as b is not equal to 0, because we did only state that a and b are non-negative, so they could be 0. AB, and the square root of a. And of course, in 6.2.3, we also saw that you can find the square root of AB, which actually, just turns out to be an extension of these examples. And Bill proved all of the examples in this theorem. He showed the quotient, product, and square root, so I won't take up any more of your time on those. Alright, that brings us to example 6.2.5, which is to show that this, the quartic root of 1 plus the square root of 2 is constructible. So of course, whenever you want to show something is constructible, you have to start with a segment of length 1, because 2 is constructible by a plus b, where a and b are both 1. That's all we have so far. So we know that 2 is constructible. And then square root of 2 is constructible, again, by theorem 6.2.4. There's going to be a lot of that theorem in this example. Using 2, a equal to 2, and using that very last example of the constructible numbers, the square root of a. So now that we know that 1 and square root of 2 are constructible, we can state again that 1 plus the square root of 2 is constructible by theorem 6.2.4. And now that all that's left to find is that the quartic root of that number is also constructible. So we have the inside of the parentheses. So now we just need that to the power of 1/4. So note that 1 plus the square root of 2 all to the 1/4 is equal to 1 plus the square root of 2 squared, and then to the power of 1/2, and then to the power of 1/2 again. And you recognize those are just square roots. By theorem 6.2.4, we know that 1 plus the square root of 2 to the power of 1/2 is constructible. And again, if you just take the square root of that number once more, you'll finally reach our desired number. showing that 1 plus the square root of 2 to the 1/4 is constructible. So one question that I would like to raise, and maybe Dr. Usa can help with this, because I know the theorem 6.2.4 states that the square root of a number is constructible, and by this example, obviously, so is the quartic root. But is that only true for roots of 2 to the n? So like, would the cubic root of a number be constructible, and if so, how would that be? Just something to think about. All right, thanks for your attention. You can ask Dr. Useni your questions.